welcome to the 8th tutorial session of problem solving through programming in C. So this is a SYM course which is floated by Professor Anupam Basu from Department of CSC IIT Kharagpur. I am Siddhant and I'm one of the 4 TAs who are in charge of this tutorial session of conducting this tutorial sessions where we will discuss doubts and sample questions which will help you out with the main exam as well as with the assignments. Okay, so this week in week 8 we learned more about functions with special reference to recursive functions. So we'll be solving questions on functions today. So let's say our first question. Uh, so the question asks that how many times will hi be printed in the program given below. So this is the program. Just go through it. You can see that the main function has been called within within the main function itself, subject to some kind of a while loop. And there is this function whose prototype was initially declared here and returns a int value, and it prints hi. So the program asks how many times will hi be printed if this program is executed. Okay, so this int I when we write, so this is basically we are defining a global variable. So global variable by default it is if it is an integer global variable, it is by default it is defined as I is equal to 0 unless you have specified some values. It will be initialized to 0 automatically for any integer global variables. Now, as I has the value of 0 and this is a function prototype, right? And in the main function, we see that there is a while loop with I as the condition, that is I is 0. Yes, it will print 0. No, it will not give an error because all global variables are similar to like static variables. So they are automatically initialized. If you just declare them, they are initialized to 0 for integers. So when we use this while loop, that is while of I, which is basically while of 0, that means this is false. So this entire thing will not be executed. It is not executed, and then it straight away goes to printf hello. So here the output of this code will be just hello. Hi will not be printed even once. So here answer will be 0 times because this loop is not executed. Okay. If anyone has any doubts, they can either unmute and speak, otherwise they can put it in the chat as well. Otherwise we'll move to the next question. So the second question also is related to the scope of the variables. So basically both this are related to something called scope of the variables and the nature of the variables, that is global or local. So variables can be of two different types according to this classification. It can be global variables and it can be local variables. Global variables are defined across all the functions. They have the same value across all the functions, and this is an example of a global variable. So this is a global variable. This int I is equal to 15, and any variable defined inside the function is called a local variable, which is local to that particular function. Okay, so in this question, it is asking what is the output of the following code. So we have a global variable, integer variable, which is I with the value of 15, initialized to the value of 15. We have given the function prototype here, and we have a main function where we are defining another variable j, which is saving the value of I to it, and we are calling I is equal to fun, which is a function. And what this function does is it defines I is equal to 25 and it returns I. Okay, so and finally it prints out something. So what should be the output of this particular code? Okay, so when this particular statement is executed, int j is equal to I. So now j is a local variable. So this j, it is a local variable and which has the scope of the main function. It has a scope which is main function. Main function is the scope of this variable j. Okay. Now j takes the value of I, and what is I here? Till now I has not been defined inside the main function. Okay. So this I basically will refer to the global variable I, that is 15. Okay, and the value of 15 will be stored in j. Now what happens in the next line? I is equal to fun. We are calling the function called fun, and what that function does is it defines this I, defines int, an integer variable called I, which is having the value of 25. So basically this I here, it is a local variable. So the same variable can have both it can be defined as a global and a local variable, and inside the function local variable will have a higher priority than global variable. Okay, so once I have defined this int I is equal to 25, whatever operation, if I print I here, if I try to do a printf statement here, and with I it will give a value of 25, not 15, even though 15 is the global variable of I. Inside this function, once this variable has been initialized to a different value, that will be the value that is of the local variable that will be taken. We have initialized I again here, we have declared I again and initialized it to a value of 25. So this I is now a local variable here with the value of 25, which we are returning to this function, and here it is saving. So this function, the return value is 25 here of this in this function call, and that value, that's 25 value, is getting stored in I. And in main function you can see that the variable I has not been defined. That means inside the main function I still refers to the global variable, not the local one, because inside the main function we have not yet declared the variable I. So this function returns 25, which gets stored in the global variable I. So this is the global I. Okay, this is the global variable I, which gets the value of 25. Now when we print, after that when we print this and we print I and j, so here still no variable I has been declared locally inside the main function. So this I still refers to the global variable, and we will have 25 being printed, comma j had the previous value of global variable I, which is 15. So here the answer will be 25 comma 15. Is this clear? Uh, so basically this particular question was to explain how this global variables and local variables work. So the basic difference is that a local variable is once it is declared inside the function, it has the scope till the end of the function. Outside that function, only global variables will have the scope. Okay, so a local variable is defined only within that function and can be used within that function, while global variables can be used anywhere in the code. Okay, so let's go to the next question. So we will soon start questions on recursion, which will require you to actually solve them using, like, you'll need to do a fair amount of writing for this, so be prepared for that. So the third question that we have is, how many times will hello world be printed? So this is the code, and it's a main function where we are directly printing hello world, and we are calling main from within main itself. So what will happen here? So this is an example of recursion, because this is an example of recursion. So basically recursion is a technique where the function is called from within itself, okay, subject to some termination condition. But here we don't have any termination condition, right? Because we have not given that if this particular condition is satisfied, they should not, like, the main function should not be called anymore. So there is no termination condition for this recursion. Just that we have just we keep calling this main within main, so it will recursively continue forever. So ideally it should continue forever, okay, because uh, this is a recursion where there is no terminating statement. So here the answer, however, instead of infinite times, it will be till stack overflow. Like, that will be the total amount of times hello world will be printed. Now, why is that? Can anyone answer that? What exactly is a stack, and why does it overflow? Okay, someone has asked a question, what will be the value of I if it is declared in the main function? Okay, I guess you're talking about uh, the second question. If, say, it is declared int I is okay, if it is declared in the main function, instead of what? Instead of the global declaration or a separate declaration here. So if you declare int I is equal to fun here, so this particular I will become a local variable in that case, and the value of 25 will get stored in that local variable I, and when you are printing I in the next step, the local value itself will be printed here, so it will be still 25, but this global variable of I will still stay at the value of 50. Here locally only the value, the int, the I which is declared locally in the main function, only that will be having the value of 25, not the global one. The global one will still be at 15. Okay, I hope that clears up that doubt. Okay, so stack basically is a kind of a data structure, you can say, or a kind of a storage space, whatever you want to call it. So, so think of it as a stack of plates. Okay, so this is some memory location. Now, when we first called this main function, that was called here. So we call it pushing into the stack. Okay, so we pushed a main function into the stack, and it went to the very bottom. Okay, now the next main function that we are going to call will be placed on top of that. Okay, and this is the second time, that is the within the main function, the first main function that was executed, the first recursion that occurred was stored on top of that. Okay, it gets pushed into the stack. Similarly, the second recursion will again occupy a space above it. Okay, so this is the first recursion, this is the second recursion, and henceforth. So at some point of time, this stack will completely get filled up with main functions, right? we are calling main function again and again. So this entire stack space, this is the stack memory, and this stack memory entirely will get filled with this main functions, and that is when this stack overflow occurs. If we try to push any more main functions, any more recursions of this main function onto the stack, it will just simply give that the stack memory is full and it has overflowed. So this is kind of an unending recursion or non-terminating recursion that we are doing, which is not advised because it will fill up the entire stack space and the stack will overflow. Okay. So just to maintain continuity, this mechanism is called pushing into the stack. Similarly, when you talk about removing an element from a stack, that is called popping out. We pop out the element from a stack. Okay, so for a stack basically is a storage space where uh, the last in is the first out. Okay, LIFO. The the last recursion, say we are recursing it for 10 times, so the 10th recursion will be at the very top, right? Think about it as a stack of plates. So the 10th plate is at the very top. So in order to remove the first plate, you will have to remove all the plates from 10, 9, 8 up till the second plate, right? Only then you will be able to remove the first plate. So it is a similar kind of thing. The last function or the last element which goes inside is the first one to get outside. Okay, so the last in, first out. This is the kind of structure that stack is. I hope that is kind of clear. If you have any doubts, you can just ask. All right. So, uh, yes, of course, there is a limit. That is what the stack memory is getting full, right? Here we are calling this recursion endlessly. Okay. So, at some point, the stack memory will get full and it will throw a stack overflow. It will say that the stack has, so there is stack overflow has occurred, so the program will stop there. It cannot, there is no definite limit. Actually, it varies from processor. It is like processor dependent. Yeah, it's processor dependent. Yeah. Uh, okay. So, okay. So now from here on onwards, we are starting recursion questions. So the solutions will be pretty long. So bear with me. Okay, so we have this main function which has a value of, we have defined an integer a which is 2048 and a sum which is 0, and we are passing that to a function called func, and that function, as you can see, it takes in these two inputs and defines a k is equal to 0 and j is equal to 0, two variables here. And there is a return statement which is if n equal to 0, then it will simply return from here, else it will return just from here. So the function termination will stop here itself in case n is equal to 0. In If this condition is not satisfied, then all these things will occur because it's a return case. So return, basically what it does is it once the return is encountered in any function, the function execution terminates there itself. Okay, it does not go beyond that. So here if n becomes 0, the function will terminate itself. If n is not equal to 0, then this condition will be false and return will not be executed. In that case, it will go to the next line, which is k is equal to n percentage 10, j is equal to n by 10, and then some sum. And then we are again recursively calling this function called func with the value j and the sum, and we are printing the value of k here. Okay, so uh, let's try to solve this. What exactly we'll get here? So I'll just give you 2 minutes to try on your own, and then I'll start solving this. So whenever there are recursive questions, these recursion questions are a bit like the solutions are a bit lengthy, but like you have to do it a bit carefully. These are easy, but you have to do it a bit carefully so that you don't make silly mistakes here and there. You'll have to do some calculations at every step. You have to keep in mind which returns to which recursion and so on. So those things you need to be a bit careful about. Okay, so let's do this. Okay, so we have a which has the value of 2048. Okay, and sum which is 0. Now we are calling func which is the first time with a value of 2048 comma 0. All right. Now when we called it this is from the main function. Okay, this will return to the main function. Now 2048 comma 0 we have called it, so here the value of k will be what? The value of k is n percentage 10, which is 8, right? The last digit. So the remainder will be 8 here. And what else? The sum here. Okay, I guess the sum. Okay, yeah, the sum comes from this variable. So the sum becomes from, it goes from 0 to 8. The value of sum is 8 now. Now we call, this is the first recursion that we do. Okay, yeah, sorry, I didn't write the value of j. So j is n by 10. N by 10, n is 2048 by 10. J is an integer, keep this in mind. So it will be 204, right? So the first recursion that we call in this particular step, which is func of 204 comma sum is 8. Okay, so this is the first recursion. And once we call this, this is the first recursion that we call. So here what you will get, the value of k. The value of k is the input, the n is 204, as you can see here. So k will be 4 and j will be 20. Sum is 8 plus 4, right, which will be 12. Now I'm continuing here. So now what we will do, we have again called func, which is func 20 comma 12. Alright, for this is the second recursion. Now for this the value of k will be n percentage 10, which is 0 here. J will be 2 and sum will stay at 12 because this is plus 0 here for this step, so it will stay at 0. And next we are again calling func, which is with j and sum, right? So this is the third recursion. Now in this we will find the value of k is 2, the value of j is what, 1, right? 0. 2 by 10, that is 0.2, which is integer part is 0, and sum is 12 plus 2, that is 14, right? Now it will again call func with 0 and 14. So this is the fourth recursion step. Okay, now n becomes 0, so it will return from here. Without doing anything, it will just simply return from here. So once it returns to here, okay, the fourth recursion goes back to the third recursion. What is the next step after the func, which is k? So here the value of k was 2. So 2, our first value is 2. Okay. Then after printing 2, that the third recursion also will get over, and it will return to the second recursion. So in the second recursion, what was the value of k? So this particular statement got over the second recursion. in the second recursion, and it goes to the next statement and prints the value of k. So what was the value of k here? 0. So our next print will be 0. Okay. Then this function gets over, the second recursion gets over, it will return to here, like after here. This is the first recursion. In the first recursion, the value of k was 4, so this will be 4. Okay. Now once that is printed, this particular recursion is over, the first recursion is over. It goes back to the one which was called from the main function. Okay, and here the value of k was 8. All right, so we'll print 8 here. Okay, now this after printing 8, it will go back to the main function. Okay, and so this particular step is done now. This from this particular statement, func a of sum, this is already over. Now we'll go to the next statement, printf %d sum. How you can see that although the value of sum keeps on changing here, it is never returned to any of the functions. Okay, like the value does not go from one function to the other. The value it does not get returned from one function to the other because it's a void type. So the value, although the value changes, it does not get returned to the previous function. Okay, it just prints some value. After all doing all this calculation, the value of sum is not returned to the previous recursion or to the main function or anything. So the value of sum will still be the same as it was here because there is no return from this particular function. So the final value we'll get is 0, which is when we print this variable sum. So D will be the answer in this case. Is it clear? Are you able to get how to solve questions with recursion? So here basically this variable sum is not getting returned, right, in any of the recursions. So the even if the value changes, it does not matter that the value changes because it did not get returned back to the main function. Okay, even in this case, there is no return value here. It's a void type of function. So there is no return value here. So the sum will be whatever the value of sum we initialized it to. So that is 0 here. So 0 will be the answer here at the final one, which will be printed. Okay. If you have any doubts, you can just ask me in the chat box. Okay, so let's go to the next question. So here, what is the error in the following program? Right, so this we have a function which is f. Which takes a integer a and it returns some integer, and we have a main function which takes a which in which we have declared a integer b, and we are calling b is equal to this function f of 20, and we are printing the value of b. So what is the error in this particular program? Can anyone um, tell that? Right, so if you don't remember this particular thing, it is a kind of ternary operator, right, which you can and it is used for simple conditional statements. It is also called a conditional operator. So the problem with this particular program is that we are trying to use a conditional operator with a return statement. Okay, so that is what here the error is. The error is that we are trying to return something using a conditional operator. We cannot use this kind of operators with return statements. However, we could have written this: if a greater than 20, then return 10, else, sorry, else return 20. We could have written this entire thing, a if else block. We could have written a if else block and that would have been correct. That is correct. We can write return statements like this, but we cannot write return statements using this conditional operators. Okay, so that is the error that we have in this particular code. Is everyone able to follow? Right. Okay, so this would be a bit hectic, this particular question. So let's get to it. So how many times will the function get be invoked if get of 6 is called from the main function? So we have a main function, say this is the function get, which is of void type. It takes an integer. If n is less than 1, then it will return. Otherwise, it will call get twice with the n minus 1 and n minus 3. So these two are the recursion steps, as you can see. So we have called it once from the main function, which is get of 6 that we have called. That is from the main function. So that is the first time we have called get. And then we are afterwards this internally it will be recursively calling this get with different values. So try solving this question. It will be a bit, you can draw a flowchart kind of where it goes from. So that is what I'll be doing while solving this question. I'll draw a flowchart of where the returns and the calls will go and so on. So try to solve this. Yes, Sashikant, your question is okay. Yeah, we can answer. If there is some particular confusion regarding any of this particular lectures, then you just need to mention that you the lecture or my name or something, so that I'll know that it's from my particular session you had this problem and the session number, and then you mention the doubt that you have, so that I can clarify that in the forum. Okay, so let's see what happens here. So we have get of 6. So 6 is not less than 1, so it will not return. Now this calls get of n minus 1, that is 5. Okay, this will call, let me just fill this up first. It will call get n minus 4. This will call get n minus 1, then 3. This will call get of 2. This will call get of 1. This will call get of 0. Okay. Okay. Now I'll start filling up from here. Get of 1 would have called get of 0 and get of 1 minus 3 minus 2, right? And get of 2 would have called get of 1 and get of minus 1, right? Get of 3 would have called get of 2 and get of 0. Get of 4 would have called get of 3, right? And get of 1. Now get of 1 would have called get of 0 and get of minus 2, right? Get of 5 would have called get of 4 and get of 2, and get of 2 would have called get of 1 and get of minus 1, and get of 1 would have called get of 0, get of minus 2. Okay, so we have completely filled up this particular branch. Okay, now the other branch, let me, let me start it from the middle. Okay, so get of 6 would have called get of 5 and get of 3, right? And get of 3 would have called get of 2, get of 2 would have called get of 1, get of 1 would have called get of 0 and get of minus 2. Okay, get of 3 would have get of 2 would have called get of minus 1, get of 3 would have called get of 0, right? Okay, so why did I stop at 0, minus 1 and minus 2? Because if it is less than, if n is less than 1, then it will simply return. It will not move to the next statement. So it will not execute the next get statements if return is executed. Alright. So that is why I just stopped if I got a value of 0, get of 0 or get of minus 1 or get of 2. Alright. So now just calculate the total number of get that is written here. So this entire branch, how many times did it really execute get? So 1, 2, 3, 4, 5, 6, 7. So 7 from here, right? And this branch 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 from here and 1 here. So total 25, right? So 25 is our answer. So here you actually did not need to write beyond get of 1 or get of 2. Once you write what get of 2 will do, you just know how many times get of the get function will be called for a get of 2. So you don't need to write that, but just for the sake of completeness, I wrote the entire flowchart how it will happen. And so from here it will like return back. Once it gets to minus 1 or 0 or 1, it will just keep returning back from here. Okay, so it will return from here, it will return from here, similarly it will return from here, and so on. It will go backwards again. Alright, so total number of times that get function has been invoked here is 25. Does anyone have any doubts here? Okay, so I see a few of you have some doubts. Okay, so the first time get is invoked from the main function, it is get of 6. Alright, and the function for the termination, so this is the condition for termination of recursion. Why do I say that? Because it occurs before the recursion steps. So these are the recursion steps, right? So this is where the recursion will occur. Once this statements get executed, the recursion will start. So before that we have a return statement, so that if a certain condition is fulfilled, the function will stop executing here itself once the return is encountered. So this is the termination condition that I was talking about. Alright. So first we mentioned the termination condition, and here the termination condition is that if get of anything less than 1 is called, then the recursion will terminate there. If get of anything less than 1 is called, then this is where the recursion will terminate. Okay, it will start returning back from here. It will not continue any further recursions. Alright. So keeping that in mind, let's see what happens when we call get of 6 when we call, then what happens? So this condition is not satisfied. This will not be satisfied until we call get of 0 or get of minus 1 or get of minus 2. Until we call this all the get functions will with this inputs, it will not terminate till then. Okay, so anything before that, even get of 1 will also further continue into the recursion. So this get of 6, when we invoke, it will call get of 5 and get of 3, right? So that is what we have, get of 5. Now once this get of 5 is called, think about it, if we send this value of 5 here, it will still, this condition is not satisfied, it will call get of 4 and get of 2, right? Now when we just let us look at them one by one. Now get of 4, when it is called, then the condition is still not satisfied, it will call get of 3 and get of 1, because 4 minus 3, that is 1, 4 minus 1, that is 3. All right, now get of 3, when it is called, it will call get of 2 and get of 0. So this 0 is reached here. So here is this won't continue any further beyond this, okay, because it returns directly from here. So this recursive steps were not executed anymore, so the program returned from here. All right, for get of 2, what happens, it will again call get of 1, because this condition is not satisfied yet, so it will call get of 1 and get of minus 1. So because this get of minus 1 is reached, so it will return here, so no further recursion for this branch. Okay, then get of 1, the condition is still not satisfied, so it will again call get of 0 and get of minus 2. So for both get of 0 and get of minus 2, the condition is satisfied, so there is no further recursion beyond this, so it will stop here. Okay, now let us, in the similar manner, let us fill up all other recursions that we have. So here get of 1 had been called, so get of 1, the condition is still not satisfied, so it will go into further recursion, which is get of 0 and get of minus 2. So here there is no further recursion, because the value returns, and the recursion does not go beyond this. Now what happened when we called for get of 5? When we executed get of 5, it would have executed get of 2 as well. So for get of 2, we get the recursion continues, which is get of 1 and get of minus 1. The minus 1, there is no further recursion, because this condition is satisfied, it returns. So for get of 1, it is not satisfied, so it will still continue with the recursion, get of 0 and get of minus 2. Okay, and this is where this recursion branches will stop. Now what about get of 3, which had been, when we called get of 6, it called get of 5 and get of 3, right? So what happens to the get of 3? So this starts recursing. We have get of 2 being called. Now once get of 2 is called, it will call get of 1, then get of 1 will call get of 0, so this returns back. Then it calls get of minus 2, this returns back. Then it goes back to get of 2, where get of 1 is now done. Get of minus 1 it calls, because 2 minus 3, that is minus 1. So here also the recursion stops. Then it goes back to get of 3 function, that execution of get of 3 function. So get of 2 execution is done, so the other one it executes is get of 3 minus 3, that is get of 0. So here also the recursion stops here, and it goes back. So now it goes back where when the get of 6 had been invoked from the main function. So the function returns here, and we have a total of 25 calls of get function. What what kind of? There is no return values going from one function to other. Okay, okay. Uh, we have to. Okay, I might show one question, or you can check the values there itself. Yeah, so we have to use some kind of a static variable there. Okay, or even if you don't use a static variable, there are ways. Like I have a sample question, probably I'll be able to, okay, I might not be able to discuss. So it was regarding conversion from decimal to octal using recursion. So there we are returning at every step, we are returning some value. Okay. So I'll okay, maybe I'll just briefly discuss that at the end. Okay. Oh, okay. Yeah, we have three more questions. So yeah. So, see, I can answer questions, especially confusions that pertaining to my sessions. So, if you have any problems with problems that you faced with my sessions, you can just mention it there that this particular session, like your problem with this particular session, the session number, and maybe you can say, okay, yeah, yeah, screenshot. You can just, yeah, that should be fine. Okay, so the next question is regarding this right shift operator. You don't need to think much about the right shift operator here. Just that what it does is it will shift the binary representation of the number by the amount mentioned here. So okay, so we are calling 435. Let us first convert that to binary, shall we? So we have 2, we have 217, right? Yeah, 217. This is 1, and then we have 2, sorry, 108, 1, 54, 1. Okay, did I make a mistake here? So point out if I make a mistake, please point it out. So 2, this is 27, this is 2, this is 13, this is 0, this is, oh, right. Yeah, thank you. So 2, this is 6, this is 1, this is 2, this is 3, this is 0, this is 2, this is 1, this is 1, and finally 0 and 1. Okay, so reverse of this. So we'll have 1, 1, 0, 1, 0, 0, 1, 1. So this is the binary representation of 435 if I've done it correctly. Now just check the calculations once. I think it is correct, but yeah, just check that once. Oh yeah, right. 6, 1. No, actually that I wrote it for this step. So when we divide 6 by 2, we get 3, right? So 0, the remainder is 0. That's what probably I meant. Or did I leave that completely? Okay, let's just check that again. So 435, uh, we divide by 2, we get 1 remainder. Then we divide by 2, 108, 1 remainder. We divide by 2, 54, 0 remainder. 27, 0 remainder. 13, 1 remainder. Right, you're right. So we'll have another 1 here, right? So we'll divide 13, so 6 with 1 remainder. Then we have divided by, then we'll have 3 with 0 remainder, then 1 with 1 remainder, 0 with 1 remainder, right? So where should I make the modification? We should have 1, 1, 1, sorry, 1, 1, 0, 1, somewhere around here. Is it correct now? Can you just check? I'll also check it again. So 1, 1, 0, 1, 0, 1, 0, 0. It's correct, right? Okay. All right. Uh, Fine. Let me just verify it. 2.7, right. Okay. So Fine. So what this right shift operator will do, so if I write this in a bit more elegant manner, 0, 1, 0, 1, 1, right? So what the right shift operator will do here, it will shift by 1. So it will shift all the elements like this, and this will be shifted, and this element will be lost. Okay, it will just go out. So if I right shift by 1, then we'll get the value of 0, 1, 1, 0, 1, 0, 1, 0, 1. Okay, so that is what this right shifting will be. Right shifting by 1. Okay, 0, 1, 1, 0, 1, 0, 1, 0, 1. Yeah, the last will be lost. Okay, so this is by shifting by 1, you will get this, and you can calculate the decimal equivalent of this. So here the question is asking that if this is the right shift operator, if I call this function with a value, this function func with a value of 435, what should be the value returned? So here we are returning the value of count. Uh, okay, let me check that out then. Okay, just a moment. So 435 binary equivalent is 1100110111. Okay. Uh, all right. So where did we do it wrong? Okay, you can probably try to do it again then. Oh, great. I'll erase that. Just a moment. Give me a moment. Let us try doing this again. Okay. Hopefully we should get the correct value. So let's do it properly. So we have 217, right? This should be 217 into 2, 434. So 217, right? And the remainder of 1. Is that correct? So this should be 108 with a okay, yeah, probably. But it's better we'll solve it again so that I'll be able to find out where I did the error. So if it does not match, we'll see. All right. So we'll have 54. This is 0. So we'll have 2. This is 27. If you find any mathematical errors here, just let me know. So we divide by 2. This will be 13 with remainder 1. This is divided by 2. This is 6 with remainder 1. This is 3 with remainder 0. This is 1 with remainder 1. And this is 0 with remainder 1. Now, is it matching now? So this will be 1 1 0 1 1 0 0 1 1. Yeah? Probably we made some mistake last time then. It's fine. Happens. So we'll take it in this manner. So basically 435 decimal in decimal will have a binary equivalent of 110110011. So when we right shift by say right shift this 435 by one value, okay, say we right shift 435 by one value, we'll have a binary of 0 1 1 0 1 1 0 0 1. So this will become our binary value in that case, and you can convert this back to decimal. I think it will be around 217 or something. You can check that. I'm not going to calculate that again. You can check it with that link he has shared. You can, so just confirm this, is it around 217 or what exactly is the value here? So 2 to the power, we have it 2 to the power 0, 1, 2, 3, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, right? So can anyone just add this up and tell me what exactly this will be? So it's 2 to the power 0, 1, 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Yeah. So can anyone just calculate this? 217, right? Okay. All right. So fine. So this is 217. That's what the decimal equivalent of this will be. So the question asks, when we call this function with a value of 435, what will be, basically what will be the value returned? All right. So here, as you can see, the value returned is count. Okay. And this will exist until this num, and we have a while loop which has num here, that is this number itself. So as I said earlier in one of the previous sessions, that anything which is not 0 is true for if condition and while conditions, and if and any kind of conditional statements. All right. So then this loop will be executed the first time when it is 4, when we do this while of 435, count is 0, it becomes 1. Okay. And num becomes 217, because it shifts by 1, it becomes 217. All right. Then the num, it's then the next iteration will be while of 217, which is still true. So this was true, this is still true. So count will number of digits in the binary equivalent. Not really, like okay. Mm-hmm. Yeah, so basically it will keep counting until this it becomes all zeros, right? Yeah, basically that's what this code does. You can think it in that manner. So that gives us an idea what exactly the answer will be here, right? What should be the answer? Right. The answer will be 9 here. Okay. There is another way. When you do just 2 steps of it, you will be able to see that it's basically what we are doing. Yeah, in a sense, the thing that he said is true. We are removing 1 digit from the right in the binary equivalent. So finally, we'll be left with 0. And until then, we need to keep calculating. Okay. Um, and in a different way also you can understand, because it is shifting right by 1 digit, that basically means we are kind of dividing it, we are reducing the entire thing by 2, uh, okay, like dividing it by 2. And so this 435, it becomes 217, 217 becomes 108, then 108 will become 54, and so on, like you can see it from here. Okay, so that will become 27, this will become 13, 6, 3, 1, 0, right? So for this count will be 3, 4, 5, 6, 7, 8, 9. When it becomes 0, after that the loop terminates. So the count value becomes 9. Is that kind of clear? There are different ways to think about what exactly this uh, right shift operator does and what the question asks here. The simple way, if you are able to understand that it will shift all the digits one by one until 0 is left, that is well and good. That is the easiest way to think of this particular problem. You just need to convert it to binary ones, and you will see that yeah, that's we have the count should be 9, right? If you have any doubts regarding this, you can just ask me. Source is previous run assignments. So previous run assignments had these questions. So that is the source. Okay, so let's go to the next question. Both of these are quite lengthy. Okay, so the first question that we have is, we have a function which takes two inputs, and under certain conditions it returns a certain value that is mentioned here. If n is 0, then it returns 0. If n percentage 2, that is there is a reminder here. This particular condition will become true when there is a reminder, right? So when there is a reminder, that is in a way you can say it is odd. It is an odd number. When n is an odd number, only then this will be 1, and hence it will be true. And then it will return this particular value. Else it will return this particular value for all other cases. That means if this is even, so this will become 0, so this condition will not be satisfied anymore, this will be false. So then in that case the else condition will play out, that is it will return this particular value. Now what we have given, the initial input to this function is f of 20 comma 1. Alright, so let's work this out, what exactly we'll get. So we have f20 comma 1. Okay, this has been called. So 20, as you can see, is a even number. So what will happen? 20 percentage to 0. So this is not going to be executed. What will be returned? F of this else part will be returned, right? So n by 2, that is 20 by 2, 10. 2 into k, k is 1, so here 2 minus 1, right? Okay, now this is recursively calling the function, so let's do the recursion. So now we are calling f of 10 comma 2, this is the first recursion. So 10 is still a even number, so the else part will still be executed, so it will be f of 5. And for this first recursion, the value of k is 2, so 2 into k, when it does it, it is 4 minus 2, which is the value of k. Then f5 comma 4, we have another the second recursion, which is f5 comma 4. For this 5, that is n here is 5, and n is a odd number. So this statement is executed. This else if statement is executed. Okay. So in that case, we have n by 2 integer. Keeping in mind it is an integer, so we'll have the value of 2 here, and 2 into k. K is 4. The value that came to this particular second recursion, that value of k is 4. So twice of k, that is 8 plus 4. Okay. Now f of 2 comma 8, that is our next recursion. 2 is a even number, so this will be 0. So the else part will be executed. So it will become f of 1 comma 2 into k. K is 8. So 2 into k is 16. So minus 8. Okay. Now when f1 comma 16 is called, so what will it do? 1 percentage 2 is 1, because it's an odd number, so it's 1. So the else if condition will be executed. So n by 2, which becomes 0, and 2 into k. K is 16 here, which has been passed to this fourth recursion. So yeah, it's the fourth recursion. So k is 16, so into 2, that is 32 minus 16. Okay. Now what happens here? F of 0 comma 32, n is 0, so it will simply return 0. So this returns 0. Because this returns 0, 0 minus 16 is minus 16. okay, and this gets returned here. This is the value of this. So okay, wait. I think I did a mistake here. So this is a this is passed as a, this will be plus, right? Yeah, because f of 1 comma 16, 1 is a odd number, so when it is called, it will execute this particular step, which is 0 comma 32. It will call f with 0 comma 32 plus k 16 here, with the k has the value of 16, so it will be 16. So it will return 16. 16 minus 8, it will be 8. Now this it will return this 8. So 8 plus 4 is 12, right? Now this will return this 12. 12 minus 2 is 10, right? So it will return this 10. 10 minus 1 is 9. So it will return this 9. So here the value finally will be 9. Is that clear? Or do you have any doubts? So finally you are getting the value of 9 being printed. So you wanted to see a case where the values were getting returned, right? Someone I think asked regarding that earlier. You can see this particular case. The values are getting returned from one function to the other. Okay, so if there are no doubts with this particular question, we'll go to the next one. The next question is, so we have a function which takes an integer x, and if x is greater than 100, then the function is x minus, the function returns x minus 10. So here it is written in a kind of a algorithmic manner. So basically this means it is a int x. This means it is return of x minus 10, okay, and else uh, it it is basically return function of x plus 11, okay, in the else part. So what will be the return of this function for x equal to 95? Try solving it. We'll need a bit more space here. uh, just see what exactly we'll be getting here. So we are passing the function n with 95, right? Now the first time we call it with a value of 95, it does not really satisfy this particular condition, this x greater than 100. So it will go to the else part. It will return what? It will return fun of fun of 95 plus 11. Okay. Now this, let us evaluate this inside path first. So fun of 106. So fun of 106 is basically it's greater than 100. So it will return, the value will be, let me write it like this, 106 minus 10, which is 96. So now what this became? This became fun of 96. Okay. Now when we called, okay, so this is basically equal to this, and all right, it's better to write it in this way. This entire thing is equivalent to fun of 96. Now this fun of 96, when we call, what will happen? It is not satisfying this particular condition. So it will again call fun of 96 plus 11, right? Now this 96 plus 11 is basically 107. So this is what fun of 107, and 107 is greater than 100. So 107 minus 10, that is 97. So this is basically fun of 97. Okay. Now this fun of 97, when we call, it is not satisfying this particular condition. So fun of 97 plus 11, which is equivalent to fun of 97 plus 11 is 108, which is greater than 100. So 108 minus 10, which is 98. So basically we are saying fun of 98. Now this fun of 98 will it is not satisfying this particular condition, so it will call fun again, fun of 98 plus 11, which is basically equal to fun of 98 plus 11, 109. 109 is greater than 100, so 109 minus 10 is 99, so this will return 99, and then fun of 99. So fun of 99 is still not satisfying this problem, so I'll just continue here itself. So fun of 99, it is not satisfying this, so fun of 99 plus 11. Okay, so 99 plus 11 is 110. Fun of 110 is 110 minus 10, which is 100. So fun of 100. Now fun of 100 is also not satisfying this. X equal to 100, it still does not satisfy this equation. So it will again call fun of 100 plus 11. Okay, so 100 plus 11 is 111. When we pass it through fun with the value of x being 111, so it is greater than 100. So 111 minus 10, 101. So it will process 101. Now 101, what exactly is this? Fun of 101. Fun of 101 is uh, for 95 it will be no. Wait for it. I'll tell you. There is a catch here. Okay. So fun of 101 basically is 91 here. So this 91, what will happen to this 91? So this entire thing got executed. Now fun of 100 was being executed, and it returned a value of 91. So this fun of 100, when we executed, the 91 will be the return value of that. So where it will go? It will go back to here. So it is the return value for this. So the return value for fun of 99 is 91. Okay. Now the same return value will again go back. So this entire thing evaluated to be 91. Now this same thing will go to fun of 98 when fun of 98 was being called. Now fun of 98 basically means we are getting 91 here, and the return value of this entire thing was fun of 91. Now this will go back to fun of 97. Now fun of 97, basically this entire thing becomes the return value came as 91. Okay, so the 91 return value, it will go to fun of 96, which is basically that is the return value of fun of 96. So where was fun of 96 being called? Fun of 95. So the return value that goes from fun of 96 to 95 is 91, and that is the result of fun of 95, that is 91. Are you able to follow? Okay, this might have been a bit complicated. So yeah, it is. Yeah, it's a bit difficult, tricky to view, but you need to just visualize that which function is being called and under that what is being done. So here, when we evaluated this entire thing, we were calling function with a value of 100, and that returned a value of 91. And where was that this function of 100 being called from? It was being called from function 99. So the value that went from here, the 91 value will be the return value for this function. And where was this function of 99 being called? It was being called from function of 98. So the return value will go from a function of 99 to 98. So that is 91. Then similarly it carries on until it goes to function of 95. So here the value that will be returned is 91. You just have to carefully solve recursion questions, because if you make a small mistake here and there, it will mess up the entire thing. So it once you get the hang of it, it will seem a bit easy, but still you have to do it a bit carefully. Okay, so that's all I had for today's class. We are already a bit late, so I'll stop here today. Um, and however, this particular lecture, this particular PDF that I'll share will have this as well. So this is basically write a C program to enter an integer and convert to octal using recursion. So just go through this entire. This is the algorithm that has been written. So this is the termination condition, that is n equal to 0. Then this recursion will terminate. Otherwise, it will keep returning. It will keep doing this particular operation and returning. So here I am finding out the remainder, and I'm calling the rest of with the rest of the number. I'm calling the function again and multiplying it with 10. So you try to calculate this out. So for 100 I have solved a trial for you here, which is with sorry, for 400, n of 400, I have calculated the octal value using this particular algorithm. So just look into this and try to understand this on your own. If you have any doubts, you can just ask me in the next class or in the forum. Okay, so we'll stop here for today. Thank you for joining. We'll meet again next week, same time, 6 to 7 Tuesday.